This is IAQ Radio, Indoor Air Quality Radio, the voice of the indoor air quality industry, with your hosts, Radio Joe Hughes and the Z-Man, Cliff Zlotnick. And now, Radio Joe Hughes.
Good day and welcome to IAQ Radio Plus. This week is episode number 556 and our last episode prior to our summer vacation. We've got a great show lined up with Dr. Matt Perzanowski, an associate professor at Columbia University. Recently spent some time with Dr. Perzanowski at the research. His research is focused on understanding exposures that lead to allergic sensitization and asthma. We spent a little time together at a conference at Ohio State University on carpet and indoor air quality, which we'll be talking about a good bit during today's interview. Let's, before we get started, thank our platinum sponsor.
IAQ Radio Platinum sponsor is John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com.
I also want to thank our gold sponsors, Particles Plus, Healthy Indoors Magazine, Gray Wolf Sensing Solutions, and AEML Inc. Laboratory. And, of course, our association sponsors, CIRI, the Cleaning Industry Research Institute, the Indoor Air Quality Association, and the Restoration Industry Association. All right, the Z-Man is not here today, so I'm going to go ahead and do the trivia question. He did send me one. You can win a cool prize by outcompeting fellow IAQ Radio listeners and being the first person to correctly answer our trivia question each week. Submitting your answer is easy. You can either email it to joe.hughes@IAQtraining, or if you're listening to the show live, text in your answer via your computer. We're sorry to report that no one identified Humphrey Tyler as the publisher whose idea it was to have a cleaning research organization, which resulted in the founding of CIRI, the Cleaning Industry Research Institute. The IAQ Radio trivia question for today, Friday, August 2019. 2019 has been sponsored by Ideas, the solution chemistry company, providing unique solutions to odor removal, surface cleaning, and decontamination problem. Today's trivia question: name the laboratory that first demonstrated the toxic effect of new carpet fumes. Now, all right, so let's go back to today's guest. Dr. Perzanowski is an associate professor at Columbia University and deputy director of the Center for Environmental Health Sciences in Northern Manhattan. His research is focused on understanding exposures that lead to allergic sensitization and asthma. The primary exposures his group is investigating are indoor allergens, combustion byproducts, and fungi. Two other major research aims his laboratory is working on are implementing non-invasive measurements of airway inflammation in pediatric population-based studies and evaluating the relevance of the hygiene hypothesis to inner-city asthma. Hello, Dr. Perzanowski. Do we have you on?
You do. Hi, Joe. How are you?
I'm fantastic. Welcome. Thanks for joining us.
Thank you.
We spent some time together here at the carpet. Let me make sure I've got the right name. The implications of carpet on indoor chemistry and microbiology over at The Ohio State University. It was a nice event put together. The organizers were Karen Danemmiller and Rachel Adams, both of whom have been on the show in the past. What I really thought was extremely valuable about the way they put this together was they also, in addition to the numerous researchers that were there and doing presentations, they had industry representatives from the carpet industry, and actually there were 4 or 5 of them there, I believe, along with John Donnie from the Cleaning Industry Research Institute. I kind of was there sort of representing our practitioner group, and I thought that really led to a great interaction between the groups. I mean, after the presentations, they would put us in a little group where we could all talk about things. I'm wondering what your thoughts were, if you felt it went as well as I did.
I would totally agree. I think that was invaluable in terms of the conference. I mean, it was nice that it was a small group, and we had the opportunity to have those small working groups, which in the end represented 4 or 5 people from academics, from industry, to have these small group discussions to talk about the presentations that we had heard. And I would totally agree that I think having both industry and academics together really led to a better conference than it would have been without.
I think it will also lead to better research in the future. What do you think?
Absolutely. I mean, if you had, in our small group, when we had the industry representative talking about sort of future practices and what's going on in the industry, all the academics were taking notes pretty quickly. I think it was nice to see, and I think we learned quite a bit about what industry's plans and what they've done in the past with carpets. And I think that kind of interaction can help us better understand the health implications, but then also work with the industry to think about future directions or improvements or things that can be done.
I got the impression too that they are doing a lot of their own research, and I don't know how privy or how open they are with that research, but they seemed like they were willing to share whatever they were doing. Did any of you talk about maybe collaborating or sharing some information?
It's a good question. Not in our group, we didn't talk about directly comparing information, but they definitely talked about the door being open. When we have these findings, to talk to them about potentially things that we would want to see. What are some improvements we can think of within carpets that would be useful? For example, I think one of the ones that came out is the carpets do trap a lot of particles. If there's a way to prevent resuspension, however that's done, whether that's in the design of the carpet or the cleaning practices, some way to prevent the resuspension, then in the end, it could really be a useful way to trap particles and reduce exposure.
Reducing exposure, that's what it's all about, huh? Let's John, why don't you put up the list of the presentations? I'd just like to kind of run down and give listeners who weren't able to attend a little highlight on what was discussed. The first one I have up here is exposure to resuspended dust from carpet. Brandon Bohr, Purdue University. Dr. Bohr actually was on the show, and he talked about the study he did where the baby, the robot baby kind of bounces along on the carpet, and they got some idea of what, how much resuspends, what particle size resuspends. And I thought that the industry folks were kind of surprised that had been done. Maybe they didn't, maybe they know, I don't know, but I wanted to get your thoughts.
Yeah, I think it's great. I mean, I think we, for a long time within environmental exposure studies, we will do sort of just air sampling in a room or to try and understand what people are exposed to. But that really doesn't do a good job of mimicking what people are exposed to, especially infants. You think infants, they're not at the same height as adults. They're crawling around on the floor. They're disturbing dust. And so to see, and of course, you can't bring infants in to do these kind of studies. So to have a mechanized way to reproducibly look for what kind of particles are resuspended is I thought a really cool experiment to examine that.
And I guess he found there is a whole lot of resuspension of that dust, and especially for children because their breathing zone is right there.
It's right there, right? You can imagine they're moving their arms around, they're on the floor. And he talked a lot about the inhalation, but I don't remember who it was who posed the question. But there's also the problem of the kids putting hands and other things in their mouths. So you can think about exposures coming that way too.
Potential for ingestion exposures, and that was very interesting. In fact, we'll come back to that when we get to one of the later presentations. The second one was really interesting because I asked a question of Brandon. I said, we have these studies on resuspension of dust from carpet. What about other surfaces? I mean, there's the same amount of dust on my carpet as there is probably on my hardwood floor, which is in the next room. And lo and behold, Dr. Andrea Farrow came on, and that's exactly kind of what she was talking about. Highlights from her.
Yeah, exactly. Showing that the resuspension of particles is greater from the carpets than it is from the smooth surfaces, which I think, I'm not sure I completely understand why that would be. Maybe there's more cleaning that happens in the hardwood floors, or the carpets just store more dust. That's part of it, but really important to understand that.
Yeah, my question was, where does that dust go? I mean, same amount of dust fell on that hardwood floor. So do we have to look more closely at, like you said, the cleaning practices? Do people clean hardwood more often or more effectively?
It would seem to me, again, this isn't my area of expertise, but it would seem to me that you're going to notice the dust on a hardwood floor a lot easier than you are on a carpet. I would imagine you'd clean more often. At least that's what happens at my home.
And then the type of cleaning is important as well. You know, are you just broom sweeping, or are you using a Swiffer type cleaner or a string mop, which I think, you know, has been shown, at least as I understand it, to not do as good of a job as the Swiffers. And then the question becomes, can you launder the Swiffers? I understand they lose a lot of their effectiveness when you launder them. So all questions that I'm sure will continue to be addressed by the researchers.
Absolutely.
All right, let's go to the number 3 here. And actually, that was you. So what I think we'll do is let's skip over that one for a minute, because we're going to go into more detail on your presentation on carpets as an indoor reservoir for asthma triggers for the second half of the show. Let's talk about Dr. Tina Raponen, assessment of fungal exposures by using air versus vacuumed dust samples. That was an interesting presentation as well. I wonder if you could give us some thoughts on that.
Sure, and Dr. Raponen is really one of the leading experts on fungal exposure and asthma, and has done quite a lot of research on environmental exposure to fungi and asthma, and so it was nice to hear her presentation. And really, she was examining the different ways that we assess exposure. So the easiest thing for us to do is to go into a home and collect a settled dust sample. We can use a vacuum cleaner with a modified filter, but she was examining some of these. We don't always know that how well what we measure in that settled dust reflects what people are actually exposed to. And so we know that samples, like the particles that get into the air, obviously to be exposed to the respiratory system, the particles have to get into the air. And so what she was doing was measuring in the air in the same homes which she was measuring in the dust, and was able to show that there was a pretty good concordance between those.
Okay. And by the way, we also have had Dr. Raponen on in the past. For those of you interested in some of her work, just go to the archives and check her out. But let's go to the next one, John. All right, number 5 was the implications of moisture for microbial growth in carpet. And actually, Sarah Haynes from Ohio State presented this, and I think actually when we had Dr. Karen Danemmiller on, who was one of the organizers of this event, she was talking about this topic. And I thought this is a very interesting topic. I think particularly for those of us in the Northeast and the Mid-Atlantic states, where in my experience over the last 5 to 10 years, relative humidity seems to be higher longer than ever. And I think the implications of that were kind of shown here in this presentation by Sarah Haynes. Matt, any comments on this one?
Well, I think the work that Sarah and Karen and Rachel are doing around this is really quite interesting to try and understand. You know, for a lot of these studies, we measure which fungi you detect in the home through the various methods, but ultimately, it's probably not what it's as important what's there as whether they're growing and what they're doing and what they're producing and the VOCs that they're producing. And so I think it's really interesting to examine the impact of humidity on the exposures on what's coming out of the carpets.
Yeah, and it appears that from my layman's perspective here, that at higher relative humidity, you see more gene expression and more potential for these fungi to cause health effects. Is that accurate to say? Or
certainly there's more gene activity, and you would expect that they potentially would then be more likely to cause health effects. I think that remains to be shown directly. I mean, in terms, it probably depends on which VOCs and which fungi, what they're producing, but the humidity is really what drives growth.
And, you know, that was another thing I found fascinating. There seems to be, and I'm applauding this, more focus on the VOC side of the equation as opposed to just the mold and the mycotoxin side of the equation. I'm seeing more focus on the VOC side. Did you get that same impression, or is that what you see in the research community?
Definitely, and I think that's where a lot of the exciting research is going towards, is trying to assess the VOCs. I think that's been challenging in a research perspective. In other words, like getting a sample from a home, we have these devices which you can't bring into the field for the most part, at least the larger scale VOC measurements. I think you can do some individual VOCs, but being able to actually assess the VOCs when we think that potentially that's what's causing the health problems. One of the associations that we see with asthma in studies around the world are most strongly associated with report of water damage or report of a moldy smell. And so you might expect then that that's related to the VOCs.
Or at least that moldy smell is an indicator of some kind of activity, metabolism that's leading to these health effects.
Sure.
And it might be the two combined. Who knows? I mean, it could be some synergistic thing where, people who are in a home with both active VOC production and, molds are more likely to have health issues. I don't know. I think we'll find out as time goes on.
Right, and I think we'll talk about it when we get to my slides, but there's within asthma, there's an examination of allergic and non-allergic asthma. And the allergic asthma is clearly going to be triggered by exposure to particles. There are proteins from the fungi that travel on particles, so those aren't the VOCs. But a lot of the studies have actually shown associations with respiratory symptoms when individuals don't have asthma, and that suggests a non-allergic mechanism. And so the VOCs could be implicated there.
Interesting. All right, let's go to the next one, John. We're doing pretty good here on time. We're getting through these real nice. Number 6. There we go, right into what kind of we were just talking about here. Does dampness increase fungal spore toxicity, connecting negative health effects and fungal gene expression? Dr. Bridget Hegarty, University of Michigan. I wonder if you could comment on this one for us.
Yeah, I thought this was really interesting. And essentially what she was looking at was gene expression of some of these target allergens. So the proteins that produce allergic symptoms in individuals, and was able to show that increasing the dampness did increase the number of the expression of these proteins that are allergens.
Yeah, I think that was one of the ones where they had I'm not real good with some of the way you guys present these findings, but it was like a box with, color changes, I guess
Right.
What is that? Tell me a little more about that, if you would.
So the various methods, one of the challenges with examining these kind of data is that you end up with lots and lots of results. So you're no longer looking at whether one fungi was more expressed than another. You're looking at, say, tens or hundreds of different proteins or different fungi. And so in order to and you could put those numbers up on a screen, but it would be really hard to visually look at that and understand the differences. And so that kind of display of the graphics where you see a color change, you can instantly look for patterns. And so with her data, you're able to see that some of those proteins were really expressed even at some of the lower humidity levels, while other ones, as the humidity increased, what you visually saw was a change in color, but what that meant was you're getting a greater expression in the genes.
And I noticed with the studies that were looking at relative humidity related changes, a lot of them were, at least at this point in time, looking at really high relative humidities. And I asked one of the researchers afterward, why is that? And they said, well, we haven't gotten to the point where we're looking at, the difference between 50% and 60% or 60 and 70. Right. Does that sound right?
Yeah, that sounds right to me. I mean, again, this isn't my area of expertise, but I would also imagine that the local humidity is important. So if you're talking about the humidity in the carpet or, behind the wall, or that, which may be really high if you have local water source.
That's important. I didn't think about it that way. So it's probably not as uncommon to have a higher relative humidity in those areas than in the building itself or the home itself.
Well, that's what I was thinking about. So we go into these homes and we put relative humidity monitors, and they sit in the home for 7 days. And so we can track the relative humidity. And I think in the 350 homes we measured, none of them had an average over 70%. And that even was an outlier. But that's not telling you about the humidity in the carpet that's on the floor. If someone spilled some water or you've got a leak, that relative humidity locally is going to be much higher.
Yeah, or if it's in a basement or on a slab or something like that. Okay, let's go to the next one, John. All right, number 7, I believe. Oh, yeah, Rachel Rush, WVU, identifying fungal exposures and examining their immunological effects with WVU. Can you comment on this one a little bit?
Yeah, so Rachel is a Ph.D. student who's working with Brett Green at NIEHS, and they've been looking at some really exciting exposures in population-based studies, and then also doing animal studies, experimental studies. And so we've actually been collaborating with them, providing some samples. And so some of the things that one of the yeasts that they've been looking at, because I guess the examination of the associations between yeast and asthma have been less common. And so one of the yeasts that they've been looking at, this Victoriae yeast, we actually see is more common in homes with dogs, and also appears to be inversely associated with asthma in our cohort study, so potentially protective. Now, I want to be a little careful about how you interpret that, but it's interesting that they're finding. And then they haven't looked at that specific yeast in their mouse studies, but I think that's their plan. But they have been able to look at some of these other fungi in the homes that grow in the homes and be able to show clear associations with the development of an allergic pathway.
And I got the impression that the yeast are a part of the fungi kingdom that are kind of understudied, that we don't know enough about them at this point.
Yeah, I agree. I think that's a fair assessment.
And I find that in the practitioner world, we do occasionally get yeast in sample results, but I don't even know what type. It's kind of generalized as a type of yeast, and I think it's actually a little difficult to without using like a molecular, without using DNA to actually sample and figure out if there are yeast present or not.
I think that's true.
Okay. Just interesting. That was the point that I had on my notes too, that yeast has been kind of overlooked in our studies up to this point, and that she's looking at that much more carefully. All right, let's go to the next one there, John. Number 8. Oh, this was interesting. I don't know how it applies to my practitioner base so much, but it was an interesting presentation. Ozone removal and primary and secondary emissions of aldehydes from carpets by Elliot Gall, I believe Dr. Gall from Portland State University. I guess he's up there with Dr. Corsi now. Any comments on this particular presentation?
Well, I thought this was interesting. I didn't realize that. So one of his major takeaways was that the carpet can serve as a sink for ozone. It takes ozone out of the air. And I mean, I had known, there are many things in a home that can take ozone out of the air. So we often think about ozone, at least with asthma, as being an outdoor exposure, because once you get inside, a lot of the ozone is absorbed. But what he was showing was the carpet actually, because of its surface area, can be a pretty significant sink for ozone, so removing ozone from the air. I think that's important to think about. And then he also showed an interaction where it was more effective at higher humidities. So one of the things I was wondering, ozone is higher in the summertime, and relative humidity also would be higher in the summertime. So I was wondering whether, maybe the carpets have an even more beneficial effect in the summertime, where you have high humidity as well as high ozone, at least in the indoor environment.
And I didn't get a chance to ask this question, but I don't know if you would know the answer or not, but I was wondering, okay, is it that the ozone is captured by the carpet, or is the ozone reacting with the carpet and there's some third, some other emission as a result?
I don't know the answer to that question.
Okay.
I think it's the latter. I think it's reacting.
It's reacting. So even though it may be removing ozone, to some degree. What the byproduct is may be something we're not really interested in having in our homes. So it just, I guess it lends you need more study on that.
Sure.
And I'm sure if we had, maybe if we'll get Dr. Gaw on sometime, because I think that would be an interesting question to give to him.
Yeah, I think he'd be an interesting person to interview.
All right, let's go to the next one, John. Number 9. Okay, interactions between chemistry and microbiology in carpets based on the chem measurements. This was Powell Mitzall. I hope I got that right. Dr. Mitzall at the University of Texas, new to the university, if I recall correctly. I think he was at Berkeley prior.
I think that's right.
Any thoughts on that particular presentation?
Yeah, I mean, I'm trying to take a look at my notes here. I mean, I thought it was, in general, an interesting presentation about the interactions. And I think ultimately thinking about what kind of VOCs are coming off of the carpets and how the underlying, what's growing there can influence that.
Yeah, and I have a note here, something, VOCs and new carpet, numerous cyclic, aliphatic, aromatic VOCs. I'm not sure why I wrote that down, but it just seemed interesting to me. He was looking at VOCs and then their role with microbial activity. I think we'll have to get him on one of these days too and help him clarify a few of these topics for us.
Seemed like he had a really interesting research agenda.
Yes. Let's go to the next one, John. Oh, before we do, I did have one key note from that one, that relative humidity is the critical factor, I think, affecting VOC off-gassing. So
right, no, that was a good point. Yeah, that was really important.
Okay, so let's go to number 10, the implications of carpet and textiles on indoor chemistry. Dr. Glenn Morrison, who has now moved over to the University of North Carolina. We've had Glenn on the show in the past, and he's always an interesting presenter. I had that they were a huge sink that may be able to be used to help IAQ if we do it in the right way. That I found that interesting, that indoor air quality researchers were kind of looking at carpet in a little different light, maybe. Did you get that feeling?
Yeah, I thought that was a really interesting direction. I have to say that, from the asthma field, we just think about it as, holding particles or potentially things growing in the carpets. And so, in general, a risk. But if you start to think about it as something that actually is trapping from the ozone or the other chemicals and maybe the particles in a way, I mean, it seems to me like the discussions that I was part of, sort of conceptualizing the ideal carpet would actually be one that trapped a bunch of particles and gases, and then you could somehow clean and then get rid of, take those things out of your house. And so I thought this was an interesting presentation that added to that.
Somebody also mentioned somewhere along the line that carpet affects comfort, and I live in a cold climate up here in the mountains of Pennsylvania, and I just can't have hard surfaces everywhere. I've got to have a little carpet under my feet from time to time. I find that the key is, though, the cleaning and the maintenance of it is vital. And so maybe we have to be kind of choosy about where we put carpet and who has carpet, because some groups are going to be more likely to maintain it properly. Others maybe aren't. Maybe they don't have the money to have carpet cleaning done annually, or at least semi-annually, or at least annually. What were your thoughts on that?
Right. I think maybe even a better understanding of how often to clean or where to clean. And one of the carpet industry individuals was talking about, understanding where the traffic is, where's the dirt going. And ultimately, at least with the work that we do, we're not so interested in the dirt per se. We're interested in the individual particles that come from, say, dust mites or cats or dogs. So understanding where those particles go and how you would clean and how often you need to clean. Maybe even, some sort of sensor to let you know that cleaning needs to be done. And in terms of the comfort, I'd also add, there are other components, like in an urban environment, having carpeted floors. If you're, in the basement or the second floor in a 50-floor apartment building, you want people above you to have carpeting, right? It reduces noise. You don't hear them banging around as much.
Absolutely. And it's a somewhat inexpensive type of floor covering as well when compared to things like, ceramic or slate or other types of floor covering can be pretty expensive. Hardwood, I think comparably, they are probably more expensive, at least when you take into consideration the installation cost. The materials may not be that much more, but the installation cost can be much more. So those are all things I think we need to take into consideration when making these recommendations. I hear all the time that we should not have carpet, that indoor environments, that it's bad for indoor air quality, but I sometimes think that's an oversimplification of that topic.
Yeah, it seems like, we know that they can serve as reservoirs for things that can cause disease. So I think we need to be careful with that. But hearing about some of these other implications where they're removing or holding exposures we think are important, it's worth reconsidering and thinking about it.
All right, John, let's go one more at least before we break for halftime here. What's next up on that list? There we go. All right, the fundamentals of carpet care. John Donnie, who has been a pretty frequent, actually, guest on the show here. I'm just curious, how did that presentation go over with the research community?
Well, it's interesting to hear that perspective and to understand sort of what the industry thinks has to be done in terms of cleaning carpet. So I thought it was an interesting presentation. As
a multi-generational carpet cleaner, John has his own thoughts about whether people should have carpet in their homes or not, and rugs as well.
Right. I
thought it went over real well. I was kind of surprised.
I would agree.
All right, next one up, John. Let's do one more. Why not? Maybe we could finish these, actually. There's only a couple left, and then we'll get second half. We'll go toward, there we go. Oh, yeah. This was interesting. Carpet issues with biocontamination incidents. It's an indoor air quality issue, but an uncommon one. This was Paul Lemieux from EPA, and he was talking about the anthrax issue and how difficult it was to kill the anthrax in carpet. I wonder what your thoughts were on his presentation.
Well, I found it a little scary, but right. But the idea was, with the anthrax, they had a really difficult time in terms of killing it. So when they were autoclaving, which is a typical way to sterilize, they would have to autoclave the carpets twice because otherwise they weren't able to kill things in the carpet. And I think his other takeaway was if there were some other event that it would lead to be quite a lot to do to get rid of the carpets in wherever that had happened.
Yeah, and he mentioned how difficult it was to dispose of them as hazardous waste, for instance, and there's a lot of bulk there, so that could get really expensive real quick.
Yeah, absolutely.
Let's go to the next one, John. Why don't we try and wrap these up real quick before we go to halftime? Industry perspective on carpet from Shaw. Actually, Troy Virgo wasn't there, and I don't know if I wrote down the lady who did their presentation. She was very interesting. I don't seem to have it in my notes here, but I'm wondering what your thoughts were on her presentation.
Again, it's really interesting as an academic, to get the perspective from the industry and hear what kind of things they're working on. And she talked a lot about how the carpet industry now is moving towards the flooring industry, and how they're thinking about all these different types of surfaces, and also had shown how there had been a decrease in carpets especially over the past 10 years, people moving to more smooth floors. So I think it's important to think about the implications of that.
She did a nice job, and I guess the thing that I took away from it was that the carpet industry does a lot of research. I mean, they know their product, they know what it does and what it off-gasses, and what the pros and cons are, and they seemed willing to share. So I thought that was nice to see. Let's go to fungal allergen exposures. Elliot Horner, Dr. Horner, who also, I didn't realize about half of these folks have been on the show at one time or another, but any takeaways from what Elliot presented?
Well, I always enjoy Elliot's presentations. He's always talking about something interesting. So it was nice to hear about his discussion about the sort of long-term issues of carpet and fungal exposure.
Yeah. Yeah, I had some notes on Elliot here, but we're running a little low on time, so I think we better move on to the next one, because this one was one that really caught my attention. I was not very aware of this issue. So it was a perspective from the Green Science Policy Institute on improvements for carpet, Tom Bruton, and he was talking about what was the, maybe you could, I can't remember.
The PFOs, right? The fluorinated compounds. And essentially, they were just talking about different chemicals in the environment that they were trying to make people aware of, that would be better if we weren't exposed to. And so I thought he gave a really nice presentation about how they would target these different chemicals to try and get them out of products, or not necessarily to ban them, but to have industry move towards not using them, so that people aren't being exposed. And I thought that in talking with some of the industry people, they had said this is an effective way. In part, when you have a commercial industry, a big component is about educating the consumer so they know what they're looking for. And so if they're aware that what they want is to have carpets without the PFOAs in it, that helps sell. And if they don't know that, then they may just be looking for carpets that, just looking based on aesthetics.
Yeah, this was on highly fluorinated chemicals, and I guess those are more of an ingestion issue for young kids, maybe, as they rub their hands on the carpet, or do they also is there also an inhalation issue there?
I'm not positive. I think it's ingestion. But
yeah, it seemed like semi-volatiles that would be, and I wasn't even aware of the issue, but the carpet people sure were, and they were very upfront about the fact that they were moving toward removing them as quickly as possible. They
right.
also interesting to note, the pipeline for doing that is a lot longer than I certainly thought.
Right.
They were talking maybe 15 years before if they wanted to get rid of them all tomorrow, it might take 15 years before they were all out of that pipeline.
That was, to me, one of the really important, useful takeaways, as an academic and thinking about the interventions and how you would go through this. And it's not just about the length of time that someone keeps a carpet in their home and it replaces it. It also goes back to the manufacturing, and then the retailers who have the carpets, and then how long length they have the stock, and all those things that make it a pretty long period of time for turnaround.
Yeah, that was really an interesting key point, I think, from that one. Let's go to the last one. I think we had maybe one more, John. Oh, yeah. Future directions for healthy homes and carpet-related research. Dr. David Jacobs. David, I've got to get him on the show. Fascinating guy. He was talking a little bit about the World Health Organization's housing and health guidelines, and that the National Center for Healthy Housing also had some carpet guidance, which I've got to pull up. Any key points you recall from Dr. Jacobs' presentation?
Well, what I really liked is what he put together, two of the big challenges that we face here in the United States are related to healthcare costs, and also have been related to housing issues, right? And that both of those have a confluence in these health issues. And so trying to think about them more holistically and how we deal with that going forward is important.
Excellent point. I'm glad you brought that up. We've got to stop and thank our sponsors. We're going to thank our sponsors for 90 seconds. I want you to stick around, though, because the second half of the show, we're going to go into more detail on Dr. Perzanowski's presentation yesterday. And I think it might give you a little different thought on asthma and how we look at asthma when we're dealing with indoor environments. We'll be back in 90 seconds.
IAQ Radio Platinum sponsor is John Don Products, where restoration and abatement contractors shop. Visit them at jondon.com. That's JONDON.com. Gold sponsors are Particles Plus Engineers and Manufacturers of feature-rich particle counters and air quality monitoring instrumentation. Learn more at particlesplus.com. Count on us. Healthy Indoors Magazine, a free online digital magazine for industry professionals and consumers. Subscriptions available at healthyindoors.com. And AEML Laboratories, free FedEx shipping, great pricing, same-day results, and never a rush fee. Learn more at AEMLinc.com. Gray Wolf Sensing Solutions, who use advanced sensor software technology and embedded computers to provide superior environmental test instrumentation. Visit them at wolfsense.com. Association sponsors are the Indoor Air Quality Association, a multidisciplinary organization dedicated to promoting the exchange of indoor environmental information through education and research. Learn more at IAQA.org. And RIA, the Restoration Industry Association, the granddaddy of the restoration industry. Network with leaders. Learn more at restorationindustry.org.
CIRI, the Cleaning Industry Research Institute. See more deeply through science and research. Learn more at ciriscience.org. That's CIRI science.org. All right, we're back for the second half of our interview. We've got Dr. Matt Perzanowski from Columbia University. And, I forgot to ask at the beginning of the show, how did you get so involved in the indoor air quality world and at the university there and your work with asthma? Is that something that came, while you were in school, or is it something you were always interested in?
Really came with my first job after graduating from college. I started working in a laboratory where they researched asthma. And to be honest, I didn't know anything about asthma before that. I didn't have any experiences with it. And it was a really intriguing challenge, a really intriguing problem. The prevalence of asthma started increasing in the United States and other places in the world in the 1960s and really dramatically increased in the 1980s. So that it's become a major health problem. And in large part, we don't understand the reason for that increase. There's been a lot of research, and we have some understanding now, more understanding about why it's increased, but it's just been a really complicated problem to understand. But what's clear is the indoor environment is one of the drivers. Exposures in the indoor environment is one of the drivers of that increase in asthma.
And it's only going to be more and more of a driver. The indoor generation is here. A lot of these folks don't ever leave the indoor environments. It's very interesting. The other thing is, I had a text question during the first half about explaining how relative humidity affects carpet off-gassing at what levels of RH or what ranges. I don't know if that was your area of expertise or not, but I thought I'd throw it out there.
Yeah, that's one I'm sorry I can't answer. I did find that was an intriguing finding that was presented, but I don't know the chemistry behind that.
Well, I'm sure we'll be following up on that a little bit with Dr. Danemmiller. I think that's her area, and she'll be a keynote at the Healthy Building Summit 2019, October 16 to 18 at Seven Springs. So get that in real quick. All right, let's jump over. Oh, by the way, one other thing that I wanted to mention, and I think you agreed with this, was that, it seemed like most of the research is looking at carpet. And there was very little discussion of the carpet backing, the carpet pad, what type of substrate it was on. And I'm wondering if that's accurate to say, or if there's more going on than I realize.
I don't know. Again, I don't know about what research is going on, but it does seem like that would be important. I don't know how important that is for the particle resuspension, but it seems like for the chemistry and for the growth of the microbes, that would be important. And I didn't hear much discussed at the meeting. So I don't know if there's ongoing research, but it seems like it certainly would be something that would be worth looking into.
Absolutely. When I tear out, my son has a little construction company. When you tear out old carpet, the backings in some cases have just fallen apart, disintegrated into very small particle pieces. And I suspect the older the carpet is, the more disintegration there has been, the higher the particulate loads are going to be in that home. But I don't think there's been any research on that I'm aware of. So
no, it'd be interesting to see.
Let's go to the slides, John. And you did this in 12 minutes somehow at the conference. I don't know if you pulled it off here or not, but let's go ahead. All right. So we were talking about carpets being an indoor reservoir for asthma triggers. Let's go to the next one. Let's first talk a little bit about what is asthma. I think many of our listeners are somewhat familiar with asthma, but I think you did a nice job of explaining this.
Yeah, I think we all many people understand what asthma does, how it affects individuals. It makes it difficult for them to get air in and out of their lungs. And what I just talked a little bit about, the cause of that, the underlying biological cause is in part you have smooth muscles wrapped around the airways. So this on your right, you can see these airways. That's just how you get air in and out of the lungs. And that smooth muscle can constrict. It makes the airways smaller. So it's just like a pipe getting smaller. It makes it more difficult to get air in and out. But also there's an inflammatory component to asthma. So some individuals have inflammation. So that's like, you can imagine cells or mucus or other things when you think about inflammation. That happens in the airways, and it makes it difficult to get air in and out of the lungs.
Okay, next slide, John.
So,
all right, interesting here.
Yeah, so what I mentioned before was there's been this dramatic increase in asthma, so in asthma prevalence around the world. So on the left, you can see this timeline from the 1960s to the mid-2000s, and you don't worry about all the detail, but you can just generally look at it, and you see that for most places, asthma is increasing. But there's quite a lot of variability between countries, between communities. And interestingly, we see that even within a city. So I've been doing my research in New York City since 2002, and I was struck by this map that New York City Department of Health put together, and I recreated it here. And what it's showing is 5-year-old kids, when they go to school, just like everywhere else, their parents are asked about questions about different diseases, and one of them they're asked about is asthma. So it's a pretty good way to get the population prevalence of asthma. And you can see that within New York City, asthma prevalence varies from around 3% to almost 19%. So huge differences in risk. And the darkest components there are right in the middle of Manhattan and the South Bronx. And those neighborhoods have close to a 19% asthma. And what's really, so about 1 in 5 kids have asthma by age 5. And you look, some of the other neighborhoods are much lower. And so we're trying to use that as a way to understand what it is about the environment, the indoor environment or the outdoor environment. Mostly what it suggests is that it's probably a lot of indoor environment, because the outdoor environment, a lot of the air pollutants we think about are going to be more evenly distributed throughout the city.
Mm-hmm. I noticed the list on of the prevalence of asthma as the different countries. Those are all pretty much developed countries. Is it similar in third world, less developed countries?
No, that's really, really interesting too. One of the things that we see that is a risk factor for asthma increasing, say, especially in the 1960s, 1970s, was it was in what we think of as the more westernized countries. And the less westernized, it less so. Now, what we're seeing is in some of the other countries, in developing countries, so there's some of these good studies in Africa showing in Kenya and in Ghana, increases in asthma in the past 20 years. And in China as well. I was at a conference in Shanghai, and they've shown an increase of past 20 years of asthma going from around 2% to up to 10%. And when you think about a city of 20 million people, that's a lot of asthma cases.
A lot of people. Let's go to the next one, John. I thought the way you described this and separated out the types of asthma was fascinating. Let's have you talk a little more on this particular slide.
Sure. So one of the really complicated things about asthma that we've realized in the past, especially in the past 10 years or more, is that asthma is not one disease. It has the same outcome. Again, the airways narrow and it's difficult to get air in and out of the lungs, but it probably has multiple different causes. And so this is just it's a complicated figure, but it's trying to highlight the different types of asthma. So for example, you have allergic asthma, but we also have asthma that's not triggered by allergy. So like aspirin sensitive. And so when you start to think about things like, well, what's the relevance of having a carpet in the home that has dust mites in it? That could be really relevant for someone who has allergic asthma. But if their cause is aspirin sensitive or obesity related, the dust mites might not matter at all.
Next one, John. Okay. This is another interesting slide that you presented here, but let's talk a little bit about this one.
So we know that the development of asthma involves multiple steps. We know that if you have a parent with asthma, then you are more likely to have asthma. So there's a genetic component. For allergic asthma, first develop allergic sensitization, and that's pretty common. That's probably half of a population. if you were to skin test or measure antibodies in your listeners, probably half of them would have antibodies to something like cats or dogs or dust mites, but not all of them would have a disease, an allergic disease. So among those who are sensitized, some develop allergic asthma. And then ultimately, asthma is a disease of exacerbation. If you have asthma, but you don't have exacerbations very often, say once a year, that's much less relevant to you than if you have exacerbations every day. And so the importance of this figure, though, is trying to say that at each of these steps, so going to being allergic, to having asthma, to having exacerbation, there may be different exposures that are relevant. So it could be that dust mite exposure is really important for developing sensitization and really important for exacerbation, but not for these other components.
Okay. And then there are also multiple concurrent exposures, which is also important.
If it weren't confusing enough, with different phenotypes, then we know that it's multiple exposures that are important. So what we had seen in New York City, and that's actually on the next slide, is this is a little complicated to go through, but we're looking at the interaction between two things, between combustion byproducts and cockroach allergen. So being allergic to cockroach is really a big risk factor for developing asthma in an urban environment. And so this is a study where we recruited moms during pregnancy, and we went to their homes and we collected dust that we brought back to the lab and measured cockroach allergen. So that's what's on the axis on the bottom, on the x-axis, where it says BLA-G2. That's cockroach allergen. And then we also had the moms wear a backpack, and with that backpack, we measured combustion-related byproducts called polycyclic aromatic hydrocarbons. That's a much more simpler way to think about that. That's soot, right? So the black soot that comes from burning diesel or burning heating oil. In New York City, if you run your finger on the windowsill, it comes up black, and that's because of the diesel exhaust and the heating oil. So we looked at moms where there was higher amounts of that soot and lower amounts of that soot. And we found that you can see on the left, it's looking at the association where how much cockroach allergen was in their bed dust and whether they developed allergy to cockroach by the time they reached school age. And so you can see that's a pretty flat line. So among those kids where there wasn't a high amount of combustion exposure, we didn't see any association between exposure to cockroach allergen and developing allergy to cockroach. Now, shift over on the right. Those are the moms where there's more combustion exposure. There you see a really clear association. If you have more cockroach allergen in the dust, the kids are more likely to develop allergy to cockroach. So again, it's stepping back. It's complicated, right? You've got this combination where it's not only having the cockroach, but it's also having the combustion byproducts. But that might help us explain why that map of New York City, of the asthma prevalence. The neighborhoods where you have higher asthma prevalence are the poorer neighborhoods. Where you have cockroach is more difficult to control, because you live in multifamily building apartments, and so you may be able to control the cockroaches in your home, but if your neighbor doesn't, then the allergen's going to end up in your home too, right? So had that going on, but then you also have the buildings burning this heavy oil, or the bus depots or other combustion sources, and they may combine to lead to more risk in those neighborhoods.
Interesting. And then you also have whether the type of asthma that the person has, right? Is that also the deal? Okay.
Well, and again, not to try and make this as complicated as possible, but here we're just looking at the development of allergy in the first place, right? So just that first step on the diagram I was showing before. So then other things may be important for asthma. And so getting back to this idea, I think I mentioned at the beginning that one of the reasons I've been intrigued with working on asthma, in addition, of course, the public health implication, it's a disease that affects a lot of children and families, but it's also complicated and it's challenging, and we haven't yet completely figured out why asthma is so common. And it may be because of these, right? I mean, it's multiple diseases, it's multiple interactions, and it's multiple steps in a pathway.
Very interesting. Next slide, John. Here we go. And then you have the issue of where the particles may, the deposition in the lungs.
Yeah, and I would imagine that your audience is familiar with this kind of idea, this concept that, the bigger particles, of course, the really big particles aren't going to make it into the air. But the sort of medium-sized particles, the nose is a really good way to filter these particles out. So so those particles won't make it very far into the airways. But the really small particles can make it far down into the airways, down into those areas where I was showing a picture of the smooth muscle. And so they can be really important for asthma.
Okay. Next one, John. Here we go. The major allergen associated with asthma. Let's talk a little bit about dust mites.
So dust mites are just microscopic. You can't see them very well with the naked eye. They live in bedding. They also live in carpets. They feed off of human skin scales, and they take in water from the air. So they need a relatively high humidity. They are common in many parts of the world where you had that relative high humidity, and they became more common as we developed tighter homes. We started sealing up our homes in the 1970s and 80s and making them a little warmer and more humid than the dust mites started to increase. And for a while, that was actually to be one of the reasons that asthma was increasing, especially in places like England or Australia, where homes were going from being pretty cold and not as damp to being pretty tight and also humid and warm. And so the dust mites can live in the carpets. So interventions against dust mites have gone back more than 30 years, and sometimes to remove carpets, sometimes to use these acaricides, which will kill the dust mites, as well as targeting mattresses and other places.
So that carpet, that older carpet, may not just have dust mite, and it may also have some kind of pesticide used to try and get rid of those dust mites many years ago.
If someone was using that.
All right, next up. Here we go. Now, this was an interesting one here. Dust versus airborne dust mite and cat allergen in homes undisturbed. Tell listeners what they're looking at here.
Yeah, so again, to make it more complicated, the particles that carry these different allergens, like dust mites, and this is just looking at dust mites and cats, are also different. And what we see is that dust mite allergen travels on pretty large particles. So this is a study where they vacuumed a home and measured the allergens in it, and they also had an air filter collecting particles at the same time. And what they were able to show is with dust mite, across this range of dust mite allergen, you can see some of those homes have a lot of allergen in their dust. That's the x-axis. But on the y-axis, you see no allergen. And that's because these particles just don't get aerosolized unless you vacuum or you walk across the carpet, or you can make them aerosolized. But it has implications for exposure. It means you're not going to be as easily exposed unless you're disturbing the air, disturbing the surface. Whereas cat allergen, you can see what's measured in the floor is pretty well correlated with what's measured in the air, and it doesn't matter whether you're disturbing it or not. So those particles stay airborne for a pretty long time. And I imagine that if any of your listeners are allergic to cats, they know this already. And you probably know someone. They walk into a room, a house, they know if there's a cat there, whether they see that cat or not. And that's because those particles are in the air.
And these are specific to carpeted areas, right? Or is that just dust mite and floor dust on any type of floor?
I think with this study, this was it was any type of floor. But I would imagine that if this came from Virginia, and I think a lot of the floors were carpeted or had rugs.
All right, let's go to the next one, John. All right, neighborhood asthma prevalence and fungal diversity, a univariate analysis. Tell listeners a little bit about what this is.
So this on the left is a map of New York City. We sampled 350 homes in New York City, so we went and collected dust samples, and then we processed those samples to look at the fungal communities in those. So this is a more advanced way of looking at using a DNA-based method to look at different molds in the homes, and so you get up to over 1,000 different species that are detected, and you can use that to say which homes have a more diverse amount of fungi. And I won't get into the details of that calculation, but essentially you can think about it as who has more types of things growing in their home. And are they how representative are they? And what we actually see is that across those neighborhoods we have higher and lower asthma prevalence. The neighborhoods which have a higher prevalence of asthma actually have a decrease in fungal diversity. And so it implies some sort of protection of this more diverse community. I want to be careful with that because we don't fully understand that why that would be. There is some implication in asthma research over the past 20 years that having more microbes around, not the ones that cause disease, but sort of the ones that don't cause disease, might be protective in the development of allergy.
Yeah, that seems to be a recurring theme that I hear in current research, that the diversity may be more important than anything. But that we've got to be careful saying that for certain.
Right, and I think what we don't know is the diversity protective, because all these species compete with each other. The fungi compete with the bacteria, and does this high diversity just reflects like a healthy community in your environment? No home is going to be without mold and bacteria. So does this reflect a sort of a healthy environment? And then when you see less diversity, is it because something more pathogenic or dangerous or causing ill health is growing there, and that's what you're seeing. But that's where a lot of research is going now.
Right. John, let's go to the next one.
This was just trying to say that diversity in New York City is really driven by the type of building that you live in and whether you have a carpet on the floor or not. Or at least when we were collecting these samples from the floor, so the carpet really is the source of the dust in homes where you have a carpet, and showing that we get greater fungal diversity in homes with carpets and greater fungal diversity in the non-apartment buildings.
So homes with carpet did have a greater fungal diversity.
It was one of the best predictors of fungal diversity. It may not appear as much on this figure here, but that's a big difference between
those. Thoughts on why?
I imagine that they're just good at growing different fungi. That it provides a source for the dust, the spores, and maybe it helps with the humidity. I don't know.
Are these all, I guess that's a question I had from earlier. Are these all viable, culturable fungi that we're looking at, or is it just everything in that dust?
Yeah, it's everything in the dust. This has nothing to do with whether it could be cultured or not, or we don't know if it's viable. It's a DNA-based methods.
All right, John.
So this is
triggers. Yeah, this is interesting.
Yeah, just other specific triggers that have been measured in dust. So, back to the PAHs, those polycyclic aromatic hydrocarbons, the soot-related particles I was talking about before, they've been measured in dust. They don't come from there, probably, but they can be resuspended into the air. Same with phthalates. The DEHP has been measured in homes with carpets and has been associated with asthma. Now, what's important to point out, and the industry, again, it was nice to have the industry there, is they said that in the residential carpets, they don't use phthalates. And so the source of this is not the carpet. The original source of this is not the carpet. It's somehow getting into the carpet. And back to some of those talks about the carpet serving as sinks for some of these chemicals and particles, that then they can be resuspended. But the source is not that.
Would the source be maybe the other furnishings in the home, possibly? Because
the phthalates are really ubiquitous in the environment now, because they're in all sorts of any plastic. They soften plastics, or any manufactured smell like an air freshener. Those all have phthalates in it.
Okay, that makes sense. All right, let's go to the next one. Carpets and indoor reservoir, again, for asthma triggers. Let's go through these points real quick here.
Yeah, so this just to summarize, what I had been talking about. The asthma is not one disease, and we're increasingly understanding that, and that means that some individuals are going to be susceptible to environmental exposures that others are not, and it's really important for us to understand, what the triggers are for an individual, and then think about how we intervene. These multiple exposures act synergistically. So I gave the example of the combustion, the soot-related particles, along with cockroach being important for developing allergy. The upside of that means that, maybe if we intervene on one of these, we can reduce asthma symptoms. So intervening on the air pollution might be effective in reducing cockroach allergy. Particle size is really important, both for exposure, getting into the air, and also where it deposits in the lung. It's clear that carpets can serve as a reservoir for things that are allergen triggers. They can also serve as a reservoir for things that produce allergens, like dust mites and fungi. And then lastly, the resuspension of the allergen triggers is really important, especially when you think about things like vacuum cleaners or other components that could be getting things into the air.
Very interesting. All right, I think is that the last one there, John? And then just some acknowledgments. Of course, we want to make sure we acknowledge the funders and so forth, and your collaborators on this. And I kind of wanted to ask one more question, if we could. Do you have another minute?
Sure.
You're interacting with all these researchers and dealing with, a very highly populated urban environment. And I'm just wondering, what do you see as the future indoor air quality contaminants or concerns that our listeners should be aware of and should be maybe educating themselves on a little more?
Yeah, I mean, I think at least within asthma, where we're going, we understand allergens, we understand their importance. So I think how those particles, how people are exposed to those particles is important. I think that's the relevance of the carpets. Do they serve as reservoirs, or could they serve as sinks? But how do they get resuspended? I think the emerging issues are probably more around the other chemicals in the environment. So the phthalates have become much more ubiquitous in the past 30, 40 years, kind of in line. I don't think they were the cause, but they did certainly increase at the same time that asthma is. And so it's important to think about how those exposures are found in the environment, and understanding, outside of asthma, how those chemicals may be related to other diseases. Thinking about how we don't bring those into the indoor environment.
Have you been looking much at the fire retardants and that issue with respect to any connections with asthma?
I'm not aware of any connection with asthma. It's clearly they've been associated with neurodevelopment issues, and so we have some researchers here at Columbia who've been looking at that. I think that's a really fascinating story. Unfortunately, that now everyone is exposed to those flame retardants, but it seems like they're being removed.
Okay. And before we go, we always like to ask, is there anything that we missed that you'd like to add, or any final comments?
Well, just that I've enjoyed this. Again, I thought the conference that was put together was a really interesting discussion between academics and industry and around the future issues of carpet and the health implications. And so it's been nice to be able to talk about that with you today.
It was a great mix, and the hosts were just fantastic. Beautiful campus there at Ohio State, the Ohio State University. Right. And, we had a great time. I want to thank today's guest, Dr. Matt Perzanowski, for joining us today on our pre-IAQ Radio summer break finale. So thank you so much for joining us. I hope we can get you back sometime and talk a little more about some of your other research over the years, and certainly look forward to seeing you at some conferences down the road.
Sounds great. Thank you.
All right. So this is Radio Joe Hughes saying thanks so much to today's guest, to my co-host, the Z-Man, who could not make it today, but will be back when we get back from vacation, to John, you got to have faith at the controls. Most importantly, to our growing group of loyal listeners, don't forget about the Healthy Building Summit, October 16 to 18 here in beautiful Somerset, Pennsylvania at Seven Springs Resort. We'll be back before that, though, with the next episode of IAQ Radio. So, and we'll keep in touch by constant contact over the holiday here or over our summer break. And we'll be back the first Friday in September with the next episode of IAQ Radio Plus.
For IAQ Radio, I'm Spike Reel saying thanks for listening.